Hello, Algebra 1 students, and welcome to our new week of home-based learning. We are in our final week of learning new content for Chapter 9, so be aware of that, and the following week we will be doing some Chapter 9 assessments. So let's dive right into 9.4.1. We are skipping 9.3.2, so please be aware of that. And here we go. It says in Chapter 4, you learned that the solution to a system of equations is a point that makes both equations true. But what about the solution to a system of two inequalities? How can you represent these solutions on a graph? How many solutions can a system of inequalities have? Okay, so the key word is back in first semester we did systems of equations, and our answer was a point that made the equations true. But now in Chapter 9, we are looking at systems of inequalities, and we're thinking, is there one point that's going to make the system true? Or maybe there's multiple points. So for our warm-up, we are going to review what we learned about graphing inequalities a few lessons ago in 9.3.1, that was just last week, by graphing the following inequality at the grid that we are provided. So we are going to go ahead and work through y is greater than or equal to negative 5/3 x minus 3. Okay, so the first thing that we have to do is graph that boundary line, and we know that it is going to be a solid line due to the fact that it's or equal to. So I'm going to go to my y-intercept of negative 3, put a point, and then I'm going to go down 5 over 3. And put a point, and then I can go back to my y-intercept and I can go up 5, and then I can go left 3 as well. Okay, so now I'm going to get my straight edge, know that it's going to be a solid line, so I can use my solid line, and I'm going to draw a line through those points and extend it all the way in both directions off my graph. Okay, so that is our solid boundary line. But then now, okay, we really need to think about, where do I shade? That is the next question. Where do I shade? So it says, what is the minimum number of points if we don't know the shortcut that we learned last week that we would need to test in order to figure out which side of the line the solutions fall on? Okay, well, how many sections do we have? Well, we have 2 sections. So what is that going to mean? We really only need to test 1 point, because if we test a point and it is false, then we're going to shade the opposite region, and vice versa. Okay, so let's go ahead and use this method on number 2. It says Orville thinks that using the point 0, 0 to test is a great idea. Why is that so convenient? Okay, well, we first have to look and make sure that 0, 0 is not on the boundary line. And it's not in this case. I'm here to tell you that if a point is on the boundary line, do not use it as a test point, okay? But when we use 0, a lot of times the multiplication kind of cancels out. So we are going to test, is 0 greater than or equal to negative 5/3 times 0 minus 3? Okay, well, like I had said, or like the problem is referencing, this just cancels out when you multiply by 0. So we are asking, is 0 greater than or equal to negative 3? The answer is yes, that is true. So we know automatically that we are going to shade in the region where 0, 0 falls. Now, if you recall last week, we said that the greater than symbol means shade straight up from the boundary line. So if I put my pen on the boundary line and go straight up, look, I'm going in the region that 0, 0 is contained in. So I'm going to shade this entire region here, and that is representing all the points that would make the original inequality true. So any point that you pick in the shaded region, whether it's decimal, fraction, nice whole numbers, all of these points are going to work. And let me also remind you that when it's a solid line, all the points on the line will make the inequality true as well. All right, moving right along to question 89. Okay, now question 89 is referencing graphs that you did on the homework. Well, actually, we did not do 932, so you guys did not do 84. So we're going to go ahead and work those from scratch. So we are going to think about two inequalities. Okay, so here are our two inequalities that we are focusing on. Y is less than or equal to negative x plus 5, and y is greater than 2/3 x minus 1. Okay, we want to think about, okay, what each would look like individually, and then eventually, what is the graph of the system of inequalities going to look like? Well, let's go ahead and start. I'm going to kind of color code by graphing this first inequality in blue. So we see that we are going to start at 5 on our y-intercept, and the slope is -1. So we're going to go down 1, right 1, down 1, right 1, or up 1, left 1. Okay, and we are going to go ahead and get our boundary line going. And again, it's or equal to, so we definitely want to use a solid line in this case. Okay, there we go. And then if we look at the less than symbol, okay, less than means that we are going to shade straight down from the boundary line. So if I shade straight down, I'm going to go ahead and get some blue, and I'm going to go straight down. Okay, so this is from section 9.3.1. This would be all of the points that would make the first inequality true. Okay, but then now we don't just care about this inequality. We also, at the same time, have to consider the inequality right here in red. So when we look at the greater than symbol, okay, we see that we are definitely going to be using a dashed line because it's not or equal to. And we are also going to be shading straight up. Greater than means up, less than means down. So first I need to make that dashed boundary line by starting at -1 on my y-intercept, and then I'm going to go up 2 over 3. Up 2 over to the right 3. And I'm going to get my ruler, or if I'm on a computer, I'm going to use a dashed line. And I'm going to go ahead and make that line and extend it through the graph. Okay, now completely ignoring the blue shading, I said that from the red shade boundary line, we are going to shade straight up. So if I go ahead and get my highlighter and get red so that I'm color coding. Okay, so these inequality problems, it's nice to have some light highlighters to be able to use. If not, shade very lightly with a pencil, and maybe we'll shade in the opposite direction. So because for the blue, I went vertically, I'm going to, first of all, establish where up is. Oh, there's the region. But now I'm going to shade in the red region. Okay, I'm ignoring the blue. And then I'm going to think about, okay, which points are the solution to the entire system? Meaning, which points will make both true? Well, in this case, we need to look at how many regions do we have? Well, I'm going to number them off. We have region 1. We have region 2. We have region 3, and we have region 4, okay? So when I have two intersecting lines, we create 4 regions out of those boundaries. Okay, well, hopefully you're looking at the region where the blue and the red overlap. Okay, so consider, let's see, what points are solutions to this system? Well, I would hope our best guess would be points where the shading overlaps. So what is that going to be based on my notes? I'm going to say that's region 3. If you notice, right here is where the blue and the red overlap. Okay, so it says on C, if you have not already done so, let's verify that what we think is really true. So let's pick a point in region 3 and plug it in to each inequality. It better make each inequality true, not just one or the other. Well, luckily, the writers of this problem made our life nice for this first one, because you can see that 0, 0 is actually a point in region 3. So we are going to use 0, 0 because it's in our double shaded region to test. So with our first inequality, I'll keep color coding with the blue. We're going to ask, is 0 less than or equal to negative 0 plus 5? Well, is 0 less than or equal to 5? Yes. Okay, but we can't be done because now we have to check it in the red. So we're asking, is 0 greater than 2/3 times 0 minus 1? Well, is 0 greater than negative 1? Yes. When you have a double yes, you know that your region is the set of points that will make the system true, the solutions to the system. Okay, now how can we be sure, though, you should be questioning this, that this region is the only set of points that make both true? Okay, well, we can simply test points from other regions. Okay, so we are going to test points from other regions. So, for example, if I look at region 1, let's get a point. 6, 0. Hopefully you agree with me that 6, 0 is a point. So if I look at the blue equation, I have is 0 less than or equal to negative 6 plus 5. Is 0 less than or equal, let me see if I can scoot down, less than or equal to, what's negative 6 plus 5? Negative 1. Is 0 less than a negative number? That is a big no. So right away, when you say no to one or the other, you know that this point is not a solution to the system. So therefore, that entire region is not going to work. Okay? Now, in reality, you would need to also test region 2 and region 4, and you will see that you're going to run into those same roadblocks of inequalities being false. Okay, so systems of inequalities utilize test points a lot. Okay, so this would be like a question, this next one, that I would expect you to be able to do by the end of this chapter. So it says, draw a graph of the region satisfying both constraints below. Start by graphing the boundary lines. That's always what we're going to do. And then test points to find the region that makes both inequalities true. Okay, now luckily we don't have to completely rely on test points because we know the shortcuts, but I do want you to understand how to use the test point. So let's look at this first inequality in blue. Y is less than x plus 2. So right away when we see the less than symbol, we know that it's going to be a dashed line because it's not or equal to, and we know less than means shade straight down from the boundary line. So I'm going to put a point at 2, and then I'm going to go up 1 over 1. Okay, up 1 over 1, and then I'm going to get my dashed line and draw that in as best as I can. Sorry, my points aren't perfect there. Okay, and then we said that we are going to shade straight down from the line. So I'm going to establish where that is, and in this case I will use vertical pencil shadings. So then on the next one, I'll use horizontal and then look for the hatch marks. Okay, now I'm going to look at the second inequality, and don't get tricked that it's kind of out of the different order, but it's still y is on the left-hand side. So I see less than or equal to means it's going to be solid. And then less than means I'm going to shade straight down. So I'm going to start at 10, and then I'm going to go down 3 to the right 4, down 3 to the right 4. Okay, then I'm going to get my solid line going. Going to draw that in. Whoops, that's not solid. Didn't select the right one. There we go. Try that again. There we go. Okay, and then we said shade straight down. So put your pencil on the line and shade straight down, which we can see that this is the downward direction, so I'm going to shade on horizontal pencil marks. But I'm only worried about the red line. You have to be able to ignore the blue for the time being. Now, how many regions did we say were created when two lines intersect? Okay, well, we have 4 regions. So we have region 1, region 2, region 3, and region 4. And remember, the regions extend forever in the direction because lines extend forever in the direction. So we are going to look for where is the overlap. Well, where is the overlap? The overlap is in region 4. So our claim is that all the points in this region right here will make the inequality true. Okay, now notice again in this problem, 0, 0 is part of this region, but I don't want you guys to think that you always will test 0, 0, because what if it's not? So maybe we pick another point. I think that 2, 0, or actually let's do 4, 0. So let's go ahead and test 4, 0, and let's see what happens. So in our blue inequality, we are asking, is 0 less than 4 plus 2? Is 0 less than 6? The answer is yes. Okay. And then in red, let's go ahead and look at, is 0 less than or equal to 10 minus 3/4? Yikes. Maybe I'll put my work. Sorry, that's getting kind of messy there. Okay, let's ask up here. Okay, is 0 less than or equal to 10 minus 3/4 times 4? Is 0 less than or equal to 10? Negative 3 times 4 is negative 12. Negative 12 divided by 4 is 3. Negative 3. Is 0 less than or equal to 7? Yes, it is. So the double yes is the only way that you can be certain that a point is a solution to the system. And you can recall that from when we'd have to plug a point back into a system of equations to check for each. Okay. Now, theoretically, if you didn't know these shortcuts right here that I'm circling in green, if you didn't know that, you would always have to test every single region, which would be very tedious. So that's why you need to master kind of, do you shade up or down, meaning up is greater than, down is less than, when you're shading for graphing two variable inequalities. All right. So now, of course, we can't just stick with 2 lines. We've got to move on to something we've been also studying in chapters 8 and 9, which is quadratics, parabolas. So when graphing the system of inequalities below, which is right here, okay, Ariana started with the boundary graph of each inequality. Remember, we just treat it like an equation. So on this first one, we're kind of not going to ask you to graph this by hand, but you need to either use Desmos.com or use a graphing calculator to go ahead and look at what is that going to be. Well, that is going to be this parabola right here. Okay, again, Desmos or graphing calculator to accurately sketch a picture. Okay, because if it's not accurate, how are you going to know which test points to look at? And then we also have, we have this equation, which you need to identify as linear. It's not x squared, it's just x. The y-intercept is 0. So we have the blue function as shown. So the first question before they ask us to do any sort of shading is, why is the line dashed but the parabola is not? Hopefully we're all experts at this point, seeing that the parabola is or equal to. And what does or equal to mean? That means that you are going to have a solid boundary. But then we see that the line is just simply greater than, but not or equal to. So that means that it is going to be dashed. Just some review. Okay. So now, how many possible solution regions are there? Carefully count each region, okay? So I'm going to go ahead and erase my highlighting right now so that doesn't get in our way. And I'm going to get my black pen and let's together count the regions that there are. Okay. Now, if you don't have to pick up your pen to shade a region, then that's all considered one region. So I'm going to start up here and I'm going to call this region 1. Okay. And then I'm going to look at this region here as region 2. So I have region 1, region 2. Now I have region 3. But again, remember, lines extend forever. So this is region 3 right here. Okay, now I have region 4, and be very careful. This is where students like to make a mistake. They like to call this region 5, but that is not region 5 because watch me shade. Don't do it, but I can shade around the parabola, and all of that is region 4. And then finally, I have region 5 in the middle there. So how many regions are there? There are 5 possible regions. Whoops. Okay, so what we want to do is we want to, normally in class, we would pick a point in each region and then see which region is going to satisfy both inequalities. Okay, but that would require 5 different test points. So let's go ahead and use our knowledge, and this is what I want you guys to get to being able to do, and let's shade based on what the original inequality says. So the yellow inequality, y is less than or equal to x squared plus x minus 6, uses the less than or equal to. So with less than, we are going to shade straight down from the parabola boundary. Okay, so I am going to get my highlighter and I am going to put my pen on the parabola and go straight down. Okay, now this kind of gets confusing for some people because it's different than a line. Now look how I'm shading straight down from the parabola. Okay, so we already see that 2 and 5 are not even options for the regions that are going to be solutions to the entire system. Okay, so we want to make sure to establish that regions 1, 4, and 3 are solutions to the first inequality. But now we need to find the overlap. So from here, if we look at the blue linear inequality, we see that we are going to shade straight up from the line. So if I grab my blue highlighter and I put my pen on the line and I go straight up, okay, I've established now that I am going to be on this side of the line. Okay, and you can shade as dark as you want, but make sure not to cover up the key kind of parts of the graph we need to see. So we see that regions, let's see, 1, 2, and 3 make the blue true. And then what did we say about the yellow? We said that regions 1, 3, and 4 made the yellow true. So when I write it out that way, maybe you can see, okay, what regions do they have in common? Well, region 1 and region 3. Now let's look on our graph. Is that where the overlap is taking place? I see yellow and blue here. I see yellow and blue here. Okay, so there is our solution set. How many regions make up the solution set to the system? 2 regions. What are they? Based on our diagram, region 1 and region 3 are the points that will make both inequalities true. Have the points to make both inequalities true. Okay, so that's your answer, regions 1 and 3. So, why in this problem is 0, 0 not a good point to use for the system? Well, let's find where 0, 0 is. Okay, 0, 0 is right here in orange. And we notice that 0, 0 is where 0, 0 is on a boundary. And I think I mentioned this earlier. You never, ever, ever test a point on a boundary line, because what it's going to do is make both sides equal. Okay, and that's not going to give you any information to shade. Will not give info for shading. Don't be the person who tests a point on the line. Okay, so that's why you need an accurate diagram. Now, to get more used to this shading, okay, we are going to look at one final problem where it's the same boundary line. So in each problem, we are using the same exact parabola and the same exact line, okay? But what has changed? The inequality symbol. It says, notice that each of the systems of inequality uses the same boundary as the graphs, but notice that the constraints, meaning the inequality signs, are slightly different. I want you to pause me real quick and see, okay, if you can go ahead and complete the shading for the system on A, the shading for the system on B, and the shading for the system on C, and then check your answers, okay? So, again, real quick, I want to name our regions the same way that we did. So 1, 2, 3, 4, 5, so that we can communicate easier about them. 3, 4, 5. Okay, now go ahead and let's shade. So on A, I see that the parabola uses a greater than or equal to. So it's going to be solid, and greater than means shade straight up, okay, from the parabola. Whoops, I'm already making mistakes. So when I shade straight up, I always suggest to start from the vertex, okay, and there I can see I cannot cross the boundary that I care about with my highlighter. So right now, regions 2 and 5 are candidates for the answer. Regions 2 and 5. Okay, but then with blue, it says shade straight up from the line. So I'm going to go straight up, and I see then, okay, I'm going to be above the line there. So when I shade straight up, I see that regions 1, 2, and 3 are candidates for the blue. So what do both sections have in common? Well, you can see that the yellow and the blue take place in region 2. So region 2 is the solution points, or has all the solution points for inequality system A. Okay, now on B, our parabola is saying shade straight up from the solid boundary line. So from the vertex, I go up and see that I'm inside of the U shape. So once again, my candidates are going to only be 2 and 5. And then I have my blue, and it says go straight down from the line. So on my blue, the only regions underneath are going to be 4 and 5. So what do I have here? I see that region 5 is what they have in common. And you can see on the picture, that's where the blue and yellow overlap. So region 5. Now you need to make it obvious when I'm grading people's work, okay, don't expect me to find the overlap, because then that just tells me you don't know what you're doing. So you need to write it out clearly what region provides the solutions. Okay, so don't expect me to know where your overlap occurs. On C, okay, on C for the yellow graph, we are asked to shade straight down. So go to the vertex, shade down. Okay, ignore the line. So what regions are candidates for the yellow? 1, 3, and 4. Okay, and then on the blue, we are going to go straight down from the line. Okay, so what regions are candidates? 4 and 5. So where is the common ground? Region 4. Okay, which is this entire region right here. Okay, so in all of these cases, we see that there's only one region that's the solution set. But please keep in mind that when you have nonlinear inequalities going on, sometimes you might have 2 regions, as you can see on problem 91, that are the solutions. So sometimes you're going to have 2 regions. Other times you're going to just have 1 region. Okay, great job today. Really make sure you're making graphs when you go through the homework in these next few lessons as well. It's great to have highlighters, colored pencils, or just 2 different colors of pens to see the overlap when we express solutions to systems of equations. Sorry, not equations, inequalities. All right, keep up the hard work, and we will talk on the next lesson.